Okay, if Ray could come up to the front, please. So what we're going to do now with these Q&A sessions is basically open up the floor to questions, and then we'll have our speakers sit at the front, and they can can pepper them with questions. And we can facilitate the discussion that way. And then, as Heather pointed out, we have assistants here running around microphones throughout the audience. Okay, so.
But no paparazzi to take our picture.
Who would like to start? We have a question for
Okay, I'll start. I'm the bravest one. Anitra Thorhog, Yale University. This is mostly to Ray, but somewhat to Lisa, too. I think there's a difference in the East Coast estuaries versus and carbon in terms of the Gulf of Mexico being very shallow, particularly on the west coast of the Gulf of Mexico in the estuaries, so that when the rivers come in, the rivers don't just flow through directly as a large wedge of carbon going out to the shelf, but rather they're really filtered by either the marshes, the seagrass in these very, very shallow accreting estuaries. I think there's a different situation between both high-energy coasts and this semi-enclosed, soft-bottom accreting basin thing called the Gulf of Mexico.
Yeah, is this on? Let's see. Yeah. No, I don't. What's just closer? Yeah. I don't disagree with that. They're very different in the Gulf, and we'll be looking more closely at it and comparing with the East Coast.
Totally agree.
all right.
So I have a question. Sorry, should I go?
Yes.
Okay. So this is for both of you. Ray mentioned that the global estimate for tidal wetland area was based on George Woodwell's rough estimate from extrapolating from the United States.
Yeah.
And I remember, and I'm going out on a limb a little bit because it's just recollection, I remember looking at those numbers for the global and then looking at the newer numbers based on the National Wetlands Inventory in the United States. And it looked like U.S. had about 40% of the global wetlands, something like that, which seems really unlikely. So I'm wondering if the estimate for tidal wetland area in the United States has increased since the 70s. And now Lisa's telling us that it's probably underestimated still. So have either of you looked at to see US versus global, and probably suggest that the global estimate for tidal wetlands is dramatically underestimated?
And I should know that, like, right off the top of my head, but I'm pretty sure it's underestimated globally as well. So there's a couple different mapping efforts that have been looking. I haven't looked at for example, Roger Sayer at USGS is doing global mapping based on vector, looking for tidal creeks, basically, like in the whole globe. But in actual numbers, the truth is I don't remember, but in general, in my head, I feel like we're underestimating because it's very, to be called tidal, most people think it has to be salt or it has to have that feature, and so we have a lot of freshwater tidal that's just undermapped, and I'm guessing nobody else in the world is mapping freshwater tidal. I can say that's another thing. It's a very underrepresented data set. In general, we're at the forefront of that, and it's still not good enough.
Question in the back?
Yeah, I'm Joachim Goyes from Columbia University. Thank you for two really great talks. My question is, have you looked at the impacts of urbanization on both riverine and marsh systems, and how do they affect the final values that you get in your models?
We're not, so this approach we're taking is this kind of steady state approach, right? So obviously not exactly true, but maybe to first order. So we're not considering changes like land use changes. I don't know if you guys have looked at that. I mean, yeah, you have some land use there.
Yeah,
how
We
much of
d-
that is urban?
Yeah, we don't have a whole lot of shift to urban within the CCAP data set. That said, a lot of the stuff is really subtle. So urbanization is like roads and train tracks and things like that that block tidal flow. So now you have a tidally disconnected system, and that whole acreage of impounded water versus non is, again, unmapped currently. So that's an important one to me. I don't think has been dealt with from an urbanization perspective.
Hi, Irina Marinov, UPenn. I'm new to this topic, so maybe this question makes no sense. But can you compare the East Coast with the West Coast? And when you compare estuaries and tides on the West Coast versus East Coast, does the underlying ocean circulation make any difference whether you're in an upwelling overall regime or not?
Well, we haven't done the, let's see, we did, for the soccer report, we have the organic carbon budget for the estuaries. And I think there's just a lot less going on along the West Coast, and I think it's mostly, I mean, there's a lot less river input, and I think the area of the estuaries is a lot smaller along the West Coast. The area of the wetlands is a lot smaller, so it's more, I don't know, the West Coast seems to me more like that interface is not doing nearly, at least that's the first look, that terrestrial aquatic interface is not really doing much to transform the riverine input, just because, well, there's less riverine input to begin with and just less going on there. What's that?
And the riverine inputs is mostly in the winter, as opposed to the East Coast. So there's a lot of differences. Actually, I point, if you're interested and you have comments that when the soccer report comes out for public review or whatever review, that would be a great thing for you to take a look at, see if it's represented in a way that makes sense to you.
I mean, I've heard that Mike Kemp has said this, that a number of estuaries along the West Coast actually get their carbon from upwelling, like this particulate material actually coming into some estuaries as a result of productive coastal upwelling systems. So qualitatively, there may be something different going on there that has to do with ocean circulation.
Bill?
Hi, guys. I want to thank you for a good talk, too. My name is Bill Miller. Currently National Science Foundation, but going back to the University of Georgia relatively shortly. I recall, and I don't remember the details, but there was a paper by Smith and Hollabaugh back in the early 80s that did a coastal carbon budget. And it appeared to me from that budget that much of the carbon, organic carbon that was coming out into the coastal ocean was being recycled, but a lot of it, probably 80 to 90%, was continuing off into the open ocean by difference because things seem to balance. And so when it struck me looking at your new model, which clearly does a better job of informing the inputs from wetlands, estuaries, rivers, things like that, you've got almost no burial, and you've got a complete wash in the atmospheric exchange. So if you look at the sinks for carbon, it appears that it's still all going out to the ocean, open ocean by difference. Did I get that right, or am I? I couldn't tell exactly what the numbers were in your budget. Has that changed in our models?
So if you think of it, I mean, I sort of have an estuarine point of view. So there's carbon coming into the estuaries from rivers. There's carbon coming into the estuaries from tidal wetlands. A fair bit is outgassed, at least in this budget. And very little is buried, you're right, in the estuary. But a lot is being transported out to the ocean. So that, in that sense, it's similar. My guess is that Smith and Hollabaugh didn't think about tidal wetland inputs. So that's a sort of new thing that's added here, and the carbon that's coming from tidal wetlands is ultimately coming from the atmosphere, I guess. It's net primary production, some fraction of which makes it as lateral transport into the estuary. So I see that kind of like as an additional input from upland sources. So I think it's not it's not too different from that. I don't know how they constructed theirs, and I'm not sure, did they even, when you say coastal ocean, Smith and Hollabaugh, that might be shelf waters, right?
Yeah.
It might not be estuaries, really.
Yeah, it was shelf.
Yeah, so that's a different, that's qualitatively different from this, which is really focused on the estuaries. You know, I was kind of raised on the, you know, broker and paying, like, box model of the ocean. There's rivers, you know, it's like the 2-box model. There's rivers coming in, and it just like goes straight into the open ocean. And so sort of what we're trying to address here is, you know, what's happening between the head of tide and the mouth of the estuary. And, you know, there's some stuff going on. There's outgassing, I would say, mainly. There's more input than we thought because we have tidal wetlands as a source of carbon to the ocean. But yeah, a lot of it is still passing through.
I'll go. I have a question for both of you. Nathan McTighe, I'm a postdoc with NOAA in Beaufort, North Carolina. Luce Marie, first, I've thought a lot about decomposition as well. And I wonder if it's almost unbelievable how the sediment carbon density profiles down core to a meter are exactly the same, even though we know organic matter's changing. It seems like it must be related to the lignin content or some other property of these plants, or the below ground biomass at least, that's just conserved. Do you think that has anything to do with it?
Yeah, I do think it has to do with it. We don't have the data. You know, that's not a piece of, that's not a normal metadata type thing. People don't report on that. So yeah, I think that would be a good place to dig.
Yeah. And Raymond, my question is really I'd just like to hear some of your trials and tribulations and strategies with dealing with taking so many different measurements over different temporal and spatial scales and scaling it into something that all talks well to each other.
Yeah. Well, I mean, there's more. I think there's more uncertainty than, you know, sort of standard error propagation will give when you're dealing with these small numbers. Honestly, it's just really difficult to estimate the error. But my sense is that standard error is probably larger, exactly for the reasons that you're talking about. So, you know, the upshot, I think, in terms of what of needs are from that, at least along the East Coast, is that we need many more lateral flux measurements. That's a real hole. Some places it seems like in different places there are different things missing. But, you know, I don't think we're going to solve it by just going out and measuring everything everywhere because it's so heterogeneous. And that's where the remote sensing comes in and some of these statistical modeling approaches. And until I think we have, you know, those kind of approaches for all of these budget terms, are we really going to be able to constrain the error well? So, yeah, I think it's overconfident in a way, you know, what I presented in terms of the budget.
Esat Atikkan from Montgomery College. How does the export and import of live organic material figure into this equation? That is, from the estuary in the form of, say, larvae, or in the form of fish coming back in? Right. And how does that figure into your calculations?
Yeah, it's not included in all, and I think that's really interesting. You're talking about migratory fish, right? Yeah, I think it's really interesting that, you know, NOAA just had a climate and fish proposal decision were made on proposals, and a group of us submitted one, and that was exactly what we wanted to look at, is what role do migratory fish. I mean, it's really interesting, right? We normally think of the rivers as delivering, you know, stuff to the ocean, but actually fish are a way to get material up into the watershed and provide nutrients and that sort of thing, and carbon, and, you know, that's not in the budget at all. Just not there. Completely unknown. Yeah.
Other questions? Okay, well, let's thank our speakers. And I think at this point we're at a break, so we'll reconvene in